Video I'm going to show you how to do AQA A-Level Maths Paper 1 June 2018 question 10. My name is Sunil Tanna. I'm a tutor and author. Details on the card. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. Question 10. A scientist is researching the effects of caffeine. She models the mass of caffeine in the body using this equation. M is equal to m0 e to the power of minus kt, where m0 milligrams is the initial mass of caffeine in the body and m milligrams is the mass of caffeine after t hours. On average, it takes 5.7 hours for the mass of caffeine in the body to halve. 1 cup of strong coffee contains 200 milligrams of caffeine. The scientist drinks 2 cups of strong coffee at 8 a.m. Use the model to estimate the mass of caffeine in the scientist's body at midday. Okay, there's 2 stages to this. First of all, we're going to find out the value of K so that we can use that equation in our second step, which is to work out how much caffeine will be left at midday. So the first step is to find out the value of K. So what we know is the amount of caffeine halves after 5.7 hours. So if you drank M0 amount of coffee, after 5.7 hours it will be half as much. So it will be half as much of M0 will be left in the body, and that will be e to the minus, and then K, and we know T for it to halve is 5.7 hours, and we have to solve that equation for K. Well, the first thing that we'll notice is that there's an M0 on both sides, so those will cancel out. Next, we will take a natural log of both sides. So we had natural log of a half. Doing natural log on e to the minus k times 5.7, we'll get rid of the e to the power. So it will be minus k times 5.7 is natural log of a half. Now, if we divide by minus 5.7, we'll have natural log of a half divided by minus 5.7 is equal to k, and we found the value of k. So if we put that into the calculator, we find that k is approximately 0.121605. So now we can use that constant to work out how much caffeine will be left at midday. So the scenario where we're taking 2 cups of coffee at 8 a.m. Would be 2 times 4, 200 grams or 400 milligrams of coffee. So M0 in this case will be 400. Midday is 4 hours after the start or after the drinking the coffee. So T will be 4. And all we need to do is plug that into the equation to work out the mass of caffeine left. So we will say M will be equal to M0, which is 400, e to the minus, we know what K is, it's minus 1.21605 times 4, and we can work out the mass of caffeine. And if we put that into the calculator, we find that M is 245.9 something, so approximately 250 milligrams is our answer. Okay, there's another part to the question on the next page. The scientist wants the mass of caffeine in her body to stay below 480 milligrams. Use the model to find the earliest time that she could drink another cup of strong coffee. Give your answer to the nearest minute. Okay, so as soon as she drinks another cup of coffee, you're adding 200 milligrams of coffee into her body. So her initial level must be 280 or less. So if she had 400 at 8 a.m., sometime it will fall to 280, and that's the time when she can drink the second cup of coffee. So here we want to find out when the exponential decay falls to 400. We can do 280 so it falls to 280, is equal to 400 e to the minus k, which was 0.121605 times t. So 280 is the level that we need the coffee to fall to before she can have the second cup, and this is how the level of coffee in her body will fall over time. So we can work out when it falls to 400. So we just have to solve for t. So the first thing we do is divide by 400. So we'll have 280 over 400 is equal to e to the power of minus 0.121605 times t. Take a natural log on both sides. Natural log of 280 over 400 is equal to minus 0.121605 times t. So t will be natural log of 280 over 400 divided by minus 0.121605. And if we put that into the calculator, it comes to 2.933. And remember, that's hours. So it will be 8 a.m. plus 2.933 hours. So we need to work out what 0.933 of an hour is in minutes. So 0.933 times 60 will come out to approximately 56 minutes. So 2.933 is 2 hours and 56 minutes. So the time will be 8 a.m. plus 2 hours 56 minutes, which will give you a final answer of 10:56 a.m. Last part of the question. State a reason why the mass of caffeine remaining in the scientist's body predicted by the model may not be accurate. Well, obviously there's a lot of things that could change. The strength of the drink might be variable. Different people may remove the caffeine from the body at different rates. This is presumably an average person. Another thing that would happen is that you would take some time to drink the coffee. You don't add all 200 milligrams into your body instantaneously. You probably take 5 minutes to drink your coffee, and so as you're drinking it, once you start drinking it, the caffeine that you've initially drank is already being removed by the time you've finished the cup. So you could mention any of these things. So you could say that the model represents an average person, any individual person may not exactly match the model. And that's the end of the question.